just as I introduce Edwin, he's the CEO of a large company. And that takes a lot of work and a lot of pressure, probably a lot of stress too, given my background. But one of the things I realized that Edwin does, and I don't know if anybody's aware, he's a jazzer. He plays the saxophone. So he does a lot of improvising from a music standpoint. So the contrast between running a big company and playing jazz. Unfortunately, I didn't ask him to bring his saxophone, otherwise we might have heard a little bit. But let me give the floor to Edwin. It's all yours.
Thank you. Thank you. Thank you, Michael. Thank you, Jose. And thanks again for inviting me for the keynote. And again, I will do my best. I'm glad I have no saxophone with me here. But again, I can tell you there is much synergy. Let's say being let's say CEO of a technology company and being a jazz player, because we improvise all the time. We improvise all the time, and also rely on a very strong COO, by the way, and a CFO. So that's a good thing. So again, a pleasure to be here, and hope we can keep it very informal. And I'll try to give you a bit of color on Teledyne, and I hope we can grow together. Let's say the optical world here. Michael and I have a lot of things in common. That's what I noticed when studying his background. I came from the laser background, so did he. So we know a lot of people. We have a lot of synergies there. So that's good. So let me go over some of the Teledyne stuff and try to keep it interesting. First of all, we are a global sensing and decision support company. We are an S&P 500 company, so we're public, and that you'll see that. We had our earnings last week. I will not talk too much about that, but we had a great quarter, but there's always a next quarter, you know? That's how it works. So a very broad, balanced portfolio. That's a good thing. So when one thing goes down, the other thing goes up. At least that's what we tell to the analyst. Yeah. You can have a cold in some of the business and you can never compensate. So that's also happening. But in basically we do well. And if you compare us with the S&P 500, we grow a lot faster and we do a lot better. So we try to keep that way. The good thing is a good understanding of our end markets. That's when you speak some of the Teledyne folks here in the audience, we know our markets, and that's essential. That also comes back to AI. You know, AI is basically worthless if you don't know your end markets. You have to tune that. That's the thing. And again, the last bullet is basically the track record. We're all technologists. All the senior executives are technologists. I think we know our stuff. We try to understand it. We try to work with the people, and that's I think our strength. Our current revenue is close to 6 billion, so a 6 billion company, 20 billion market cap. So it's getting bigger. Let's say it's difficult to stay under the radar. You will see us in harsh environments, so deep space, deep sea, across the spectrum in very very extreme conditions. You will also see on the other axis between healthcare, let's say, where we really try to help the patient in every step. I will give you some examples. And also in defense and security, where we try to be the barrier between bad things happening, and everybody knows the examples currently happening, and good people. So that's what we try to do. You will see us in defense, not in offense. We try to be, let's say, the radar. We try to be the capturing, let's say, the danger here. This is how we show ourselves to the analysts, to the investor community. We report in 4 different segments. Digital imaging, which is the biggest one, 56%. Instrumentation, 23%. Engineered systems, 8%. And aerospace and defense electronics, 13%. This is not so interesting for this community. I'd rather talk about end markets. That gives far more visibility here. But the good thing is the consistency. We always report the same way. That basically means that the analysts are not confused. Yeah. When we bought FLIR, they reported in so many different ways all the way back, which was very very confusing. Yeah. It took us a lot of time to understand that. We don't do that. We report in these 4 segments, and we keep that for the time being. If you look at our business, about 25% is government, call it defense. 75% is not defense, it's all commercial business. So that's important to know. Then, as Michael said, we did do a lot of acquisitions. So we did 72 acquisitions. Basically, number 72 is happening this quarter. We will buy Q-Optic and carve out of accelerators. That will happen this quarter. 72 acquisitions, about 12 billion in spending money on these really good things. And the good thing is that if we buy a company, yeah, we keep the management, we keep the culture of that company, and we try to work on synergies. Yeah, we try to look at the commonalities between the different groups, and that's a very healthy way to do acquisitions. Our revenue growth, and I will not show too many financials today, but our revenue growth is okay. Yeah, we grow faster than the market. You could ask me, why didn't you put 2024? You had your earnings last week. Because I had to give the presentation 2 weeks ago. That's a very bad excuse, by the way. Earnings were good, cash was good. Let me not talk about that. Read our reports, and you will see it. It was okay. Next slide. Let me see. There you go. Our facilities. We have about 250 facilities, slightly more even. So just to give you a few examples, we are in London, in Chelmsford, where we do most of our vacuum products. And vacuum products doesn't sound very sexy, correct? Doesn't sound very sexy. But I can tell you that in 98% of all radiotherapy equipment, cancer treatments, our tubes are in, our magnetrons are in, which is very important. So saving lives there. So that's the way we attract young people to work for that group. Yeah, not vacuum technology. Some of our technologies here, we like that, yeah, but that's not the sexy word here. Then our facilities in Grenoble, our facilities in Montreal, basically in Bromont as well, where we have 2 of our MEMS fabs, one in Bromont, one in Edmonton, Alberta, where we do a lot of nice stuff. We have our marine businesses, underwater vehicles in San Diego. We have our vehicles, ground vehicles in Baltimore. A lot of things happening in Sweden and in Huntsville, where we work also on the Artemis rocket. We make that adapter unit. There's a better picture later in the presentation, by the way. The tapered unit. Yeah. So when you see a launch, everybody's giving applause. You know, when that rocket is going, the Artemis rocket, the first one went up. The second one is about to go around the moon, and the third one will land on the moon. Yeah, the astronauts will land on the moon. That's the plan. Everybody claps when the rocket is going. You will not see the Teledyne folks clapping. They will clap only at 8 minutes and 15 seconds when that adapter stage is going. So that's Teledyne. And of course, machine vision. We are here at Photonics West. So in bottom right, you see our Toronto, which is basically Waterloo, Montreal, where we have our machine vision activities. And we have a lot of scientific people here. So our scientific cameras is the same thing. Yeah, that's high-end cameras. That's what we love to do. You will not see us in the common stuff. We will always be in the high end. At the introduction, Michael spoke about 1969. 1969 is an important year, and it combines a lot of things we do. Yeah, 1969, we had the moon landing. Yes, we talk about the moon here. We talk about Mars, we talk about the moon. In 1969, we had Woodstock, yeah, which is music, okay? 1969, we also had the invention of the CCD. Bell Labs and Philips, always competing with each other. That was the thing. So the CCD was invented in 1969. That's why it's such an important year. I was 5 years old, by the way. End markets and main applications. This is the way our customers, this is the way hopefully you guys should look at us. So we are in 8 different end markets. You can maybe define 9, you can maybe define 7, but I see 8 markets here. Healthcare, our defense markets, our aerospace markets, energy and infrastructure, test and measurement, safety and security, inspection, and maritime. These are sort of the end markets, and we'll go in somewhat more depth, and I'll give you some examples. I don't want to be 100% complete here on this. I will try to keep it light. These are our end markets, and hopefully you connect with Teledyne with each of these end markets. So if you talk about technology, we have some very nice differentiating technologies. First of all, we have our CCD lines, 6-inch and 8-inch lines. Probably 8-inch lines are only 2 survivors with CCD. That's Hamamatsu and Teledyne. So having these fabs, 8-inch. CCD is still a very, very low noise CMOS device with very special steps. and very unique. That's why we keep it. Hamamatsu, they have the same idea. They do that, a very smart move there. CMOS design. We have a lot of good CMOS designers, and we basically do everything on top of the CMOS process. So if there are special processes needed, we do that in our MEMS fabs. Our cooled and uncooled infrared technologies, both in Goleta and also in Canada, where we do a lot of infrared, both in cooled and uncooled. High power vacuum tubes. I already gave the example about Chelmsford, but we do it also at other sites. Very, very important. Like I said, saving lives. High frequency electronics and components is probably trivial, but it's absolutely not trivial in making these things. Very, very important. Our MEMS technology, I will talk more about that. And then complementary sensing technologies, like think radar, think about biological sensors, think about chemical sensors, all these type of things are optics. They're all very complementary technologies which we have. So we're very proud to have these differentiating technologies. We keep them. Yeah, we will not sell them. These are our differentiators. So what I tried to do, with a lot of help, by the way, I didn't do this all myself. Yeah, we tried to define a select group, let's say, of high performance sensors. So of course we have our image sensors, and think about that from the gamma domain to the terahertz domain, long infrared domain, all these different sensors. But then we go beyond that. Yeah, you see PNT, position, navigation, timing. You see sonar. You see MEMS. You see all these type of things. I don't want to be complete, but this is just a spectrum of what we cover. Very important sensing blocks or actuator blocks. Then what we do, we try to put decision support. And decision support works better, AI, let's say, works better if the data out of your sensor is more accurate. If you get more data, more accurate data, your AI becomes better. This is sometimes what I see in the news. Sometimes they see the opposite. Oh, your AI can do everything. I was last week, 2 weeks ago, I was talking with a good friend. He's here in the audience, by the way. And we were talking about pictures of the moon. If you take with your cell phone, if you take a picture of the moon, yeah, and you see that picture and say, okay, yeah, it looks like the moon I took a picture of. Yeah, it can be completely inaccurate. Yeah, because your AI is basically saying, I know what a moon is, and this is your moon, okay? So you don't care, you took the picture. But then do the same thing with cancer. Yeah, trying to take an image of cancer. If you're not accurate, yeah, it can be a life-threatening situation. So that's a different story. So you need enough data, you need enough information out of your sensor to make your AI accurate. That's a very important thing. And then the last thing what we do, we try to put our processing very close to the sensor. So edge processing. We try to do that very accurate for different reasons. So the two messages I want to bring that indeed, in a hardware company, making accurate sensors is critical. Yeah, it's really critical for efficient AI, and again, doing things close to the sensor. These are the two messages I want to bring to this group. Okay, now example. If you put these sensor blocks, and you look at, let's say, all the healthcare end markets. So we do, for instance, real-time X-ray, and some of the people here work in that field. Yeah, we make very, very sensitive X-ray detectors, so that you can work with a low dose. Not so much for the patient. The patient will not undergo these treatments a lot of time. I hope not, at least. Yeah, but the doctor is doing that every day, with his or her hands in that beam. Yeah, that basically means the dose has to be very low. It has to be real time, and it has to be still giving a good image. So we're pretty good in those things. Endoscopy, very small sensors, very sensitive, go in the body. Yeah, that's another field. Ophthalmology, where you basically look at the shortwave infrared, mostly shortwave infrared. You look at different depths in the eye, and I can tell you, we work with the top 5 in that world in ophthalmology. It's a big market, very big market. Radiotherapy, I gave the example already about cancer treatment. Very important, of course, still the best way to treat cancer. And then genomics, DNA sequencing. Yeah, very important. Of course, it comes back to our MEMS fab, where we make different types of MEMS devices. So that's the healthcare spectrum. Women's health becomes more and more important. So some of the nice IP we have is that we compress the breast, which is very, very painful. Yeah, if you can imagine, it's very painful, but you still want to make a good image. So what we do is we balance that. We make sure that the compression is not too severe, and we balance it with a good image. So that's a very, very important IP and very important for our customers, very important for our OEMs. The other thing we do is that thermal imaging is now so sensitive that you can do mammography in thermal. Yeah? So there are different examples that was not possible, by the way, 5 or 10 years ago. That's only possible because these thermal devices are getting far more sensitive, and it is possible because of our AI. So in this case, AI works very well to do a very good diagnosis. And this is, again, a very less painful and a very easy way of making an accurate mammogram. So important. Women's health is becoming far more important, and we're very focused on that. Defense. The different angle, yeah? Here, what is here important is night vision, is the surveillance, the underwater vehicles, the nano drones. In Norway, we make these very, very small drones. You don't hear them. We had a board meeting, what was it, a few years ago, we had a board meeting, and in that boardroom, we did fly the helicopter. The board members didn't notice it. Yeah? That's the best way to demonstrate how that thing works. By the way, also their hearing was, but I never said that, of course, yeah? Threat detection is the other example. So instead of talking too much here, let me give you a quick 1-minute video, and it shows some of the examples in high-performance surveillance, both in visible and infrared, where we look, by the way, 25 kilometers out, and we still do what we call ranging, passive ranging. So you don't have to send in a laser, which basically says where you are. No, you do passive ranging. You detect that vehicle, that boat, or whatever, yeah, and it's a very good way of doing it. Then our ground and underwater vehicles, our airborne vehicles, and then our threat detection, CBRNE, and other kinds of detection methods. So this video says it all. It's a 1-minute video. Not only defense, it's also with police forces. It's, you see the night vision. That's the nano drone. So this is, let's say, helping and protecting a lot of people. Think what's happening in Ukraine. A lot of our devices are being used at the moment by active forces. Okay, aerospace. Aerospace, both space imaging, missile warning, satellite communication, space systems. I spoke about the Artemis, and aircraft controls, so in commercial airspace. A lot of imaging capabilities, RF capabilities, of course, for satellite communication, our PNT, position, navigation, and timing for different devices, and of course our air and water quality for quality in air quality, let's say in aircraft. That's another thing we do. One of the best examples is always the James Webb Telescope. 95%, I think it's 98, yeah, 98% of all pixels used in the James Webb Telescope, which was launched in 2021, is coming from us. And that telescope is basically looking back 13 billion years, just after the Big Bang. And it's still giving every day very nice images, very, very nice images in multispectral. So we're very proud to be on this mission. And by the way, this is not the only mission. We were on 250 missions we were. So, and this is an ongoing thing, both in infrared, both in visible, and very good synergies there. Next slide, let me see. Okay, space situational awareness, missile defense, another important topic. When a missile is launched from whatever place on Earth, yeah, and you detect it by with your satellites, you have to be very, very fast. So the processing has to take place at the satellite. Yeah, you have to process it there, and you have to send minimal data to the ground, and basically decide already at the satellite if this is an enemy missile or if it is something else happening, and then you react. Yeah. So what you need is very low latency. You need to be very, very fast. It all has to be radiation hard, because these are harsh environments, low temperatures, high temperatures, a lot of radiation. So all these things is not trivial. If you make a DDR4 RAM, Yeah, you can buy it for very cheap, let's say 16 gigabytes for normal applications. You cannot do that for space. It's not available. There's one device available, and that's a 16 gigabyte DDR4 from Teledyne. So what you see, especially in space, where everybody is using normal components, they accept, let's say, that 10% of the satellites are not working. You cannot have that in missile defense. You cannot have it. It has to work, always has to work. So that's the reason that these components are critical. And yes, they are a bit more expensive, but they are critical and they have to work. Energy and infrastructure. Think about LiDAR systems where you scan the Earth. Think about airborne survey. Think about asset management, mapping, energy exploration. All these things were active, both in the air, underwater, on the ground, using different technologies. I will not go over all these technologies, but that's what we do. Again, a nice video on Teledyne construction. This is, again, harsh environments. We have to do condition monitoring. Think about these mining applications where there's a lot of dust and a lot of bad air, and you have to create a safe environment. You have to work, these things have to work on harsh environments. So that's basically what we do. Here you see the thermal examples, all thermal cameras, but the same thing with acoustic cameras. Yeah, they don't provide an image, they provide an acoustic signal. So that's happening in what we call Teledyne construction, a combination of the different business units working together. Test and measurements. Electron microscopy, spectrum analyzers, protocol analyzer, oscilloscopes. LaCroix is a brand in Teledyne. By the way, I forgot to talk about branding. Of course, we use the Teledyne brand, but you know us as FLIR, you know us as Raymarine, you know us as DALSA, you know us as E2V. These are the important brands we use. Air quality testing, environmental testing, all these things happening in test and measurement. For this reception, I thought, okay, I'm not going to show you an oscilloscope. I'm going to show you an interesting video, which I thought was very interesting. Let me see. But I'm extremely biased, of course. So on the left-hand side, you see 1,000 frames per second visible image on top left. 1,000 frames per second. You see a ball going, which is blown out of a bottle. And on the bottom left, you saw the gas in thermal. Also 1,000 frames per second, which is not trivial, by the way. And doing a 1,000 frames per second image in thermal is not a trivial thing. So if you combine these images, pixel fusion, you get this situation. Oops, no, you get that situation. You get. Go back. No, further back. Okay. Again, you see the individual images, you see the gas on the bottom left, and then here you see the combined, you see the ball and the gas in a fused image. This is used a lot now by our customers. Again, this is 1,000 frames per second in the thermal domain. Again, not trivial. Safety and security, intelligent traffic systems, firefighting, automotive safety, perimeter security, gas sensing, all these things are there for safety and security. Also here a few examples. Traffic management. This is one camera. I wish there were more cameras, but one camera making basically a 3D image of all these cars and doing basically the ranging and doing classification. The same thing with, if you look at all these different monitors. Yeah, you can imagine if one person has to watch a tunnel. Yeah, this is one tunnel. Yeah, you cannot do that. You need AI. So again, this processing has to be very close to this sensor, has to be very close to the camera to do these analysis. So that's basically what is happening. Gas leak detection. Again, at a very safe distance. This is meters and meters and meters away. Yeah, looking at this plant. And there's a leak. Now, what do you want to know? The owner of that plant he or she doesn't want to know what kind of gas it is. No, they know what kind of gas it is. They want to know how severe is the leak, how much gas is coming out. We do a volume calculation, and we know exactly how much gas is coming out. So they know if they have to call a service engineer, or they have to call the fire department, or they have to evacuate California. That's basically the three things you like to determine, correct? This is a very nice way of detection, a very nice way, and we work with all the big oil and gas companies in the world on this. Inspection goes further. Factory automation, food inspection, condition monitoring, battery inspection, and logistics. A lot of different modalities. To be honest, if you look at these four modalities, you look at space, and you look at underwater, and you look at healthcare, and you look at defense, basically you have to look in the middle as well, which is basically our inspection business. Our inspection business is a very, very healthy business, because the solutions are not that simple, Everything has to do with high speed, high sensitivity, multimodality, and that's what you see in this example. Factory automation, thermal imaging. You see that thermal image on the left there. Non-destructive testing, using X-ray for all these nice NDT solutions. And then preventive maintenance, again, an infrared image, but you see on the bottom right, you see acoustic cameras. Think about a process engineer. If you're a process engineer, you walk a plant, what do? You listen, yeah? Hey, this sound is not great, yeah? It's different from what I expect. That's what that camera is doing. It has 124 microphones. By the way, the microphones are made in our MEMS lab. And you go with that device, and the device is listening to the plant. So you do a lot of preventive maintenance. It's a very interesting concept, and it's used a lot especially in plants where all the expertise is going away. Yeah? You used to have very good experts in all the plant. Now you can automate this thing. Inspection goes in more directions. 1D for mask and wafer inspection. Of course, our semiconductor industry is very important. They use the Teledyne 1D cameras. 2D, mostly for semiconductor and display inspection. 3D for PCB inspection, where you have the third dimension. And then again, what we call 5D is the combination between 2D and 3D at the same time. So if you want to do packaging, you want to do barcode reading, and also measure the dimensions of the package, you like to have that image at the same time, 3D and 2D together. We call that 5D. For this audience, that's a very commercial way of explaining, of course, but it covers, I think, the message here. Maritime, my last example. Yeah, we do a lot there. We do thermal, maritime thermal. Again, if somebody falls overboard at night from a boat, yeah, the only way to find that person is thermal. Yeah, that's probably the only way. So thermal is very, very important, especially in our ray marine business. Our ray marine business is using a lot of thermal. Commercial radar, sonar, and leisure electronics for that type of boats. And of course, the guy helping me with this presentation, he's a big sailor. So I was voting for a Coast Guard video. He wants to have a sailing boat. So we have the sailing boat here, which is a race boat, by the way. They like to use the best of the best, so they use ray marine. And this sailing, this thing is compensating for all the movements of the boat, and is giving you great data. So this is helping a lot. Ray marine is doing fine. So to summarize everything, basically what Teledyne is doing, we make wafers, we make components, we make subsystems, we make integrated systems, and we make autonomous systems. So we go up in the integration level. At the same time, we do decision support, and we try to do that decision support as close as possible to the component, to the wafer even. You know? So that is basically the message. We try to do that as close as possible to the wafer. Another good thing about that is that if a customer has IP, we have a lot of IP, but if a customer has IP and you want to protect your IP, you try to do that as close as possible to your component. What we can do is we can put extra layers in our process to basically hide that IP from our customer. That's another very good selling item, and that's being used a lot. Then, very important, our two MEMS fabs, especially the one in Bromont. Across the street, we have a research institute together with IBM. It's called C2MI. There's a lot of funding going into C2MI. while the US and Europe have the CHIPS Act, Canada is basically directly funding these fabs, which is a very attractive way. So there's a lot of attention right now in the Bromont area, and you will see, hopefully you will see some press releases over the coming days, where the Canadian government is really investing in a lot of things. We do the same thing. We are the founding partner of the C2MI, and we have 300 and 200 millimeter capabilities. The interesting thing maybe for this audience is that this is a medium scale fab. So you don't have to go to the TSMCs and the global foundries with big volumes. No, you can go to a medium scale. We do about 140,000 wafers per year. That's who we are. So we have a really nice scale-up plan for if you have, let's say, an R&D fab and you want to scale up. So that's a very good thing. Last but not least, we are a leader in sensing and decision support. I hope that is clear, and I hope the Teledyne name becomes a bit bigger here. I try to convince you that efficient sensing, so making good hardware, getting good data, helps you to make AI far more efficient and more accurate. And then last but not least, decision support. We do it very close to the sensor, both for bandwidth reasons, but also to be very accurate and have low latency to be very fast. So that's what I have for you today. Leave it now to Michael for questions.
Thank you very much. Thank you. So I got a few questions here, but I'll only ask a couple and then I'll open it to the audience. So we saw here automation, we saw sensing, getting close to the sensor. We even heard the term AI. I think today we heard a lot about AI in the marketplace. So my first question is, has the AI-related hardware market, at least from a sensor perspective, influenced your company's priorities?
Absolutely, and let me give you another example of AI. I gave you some examples of AI in our products. We also use AI in our manufacturing. Yeah, we use a lot of, let's say, defect analysis, which is also AI, in our production lines. So you see that happening also. Things becoming far more efficient. Yeah, so AI will have a big impact. But again, being a hardware supplier and knowing our end markets, I think AI will help us a lot, trying to stay accurate.
Interesting.
Yeah.
All right, I got a different question. I mean, this is more of a photonics as an industry question. I mean, we've seen here on this board here, what can you do for others? What can others do for you? But my question is, Optica itself, how can Optica help you? And we've recently put together a board of trustees of CEOs of major corporations. What's your perspective on this as this moves forward? I know I don't think I've prompted you and given you any idea about this question, but what do you think about that?
I think first of all, I think Teledyne will add, and I'm a member of and I will try to add as much as I can. I think optics becoming more and more important. I think it's still very fragmented, and I think we don't have to acquire companies. We can just making sure we work together, and some things are very complementary. I already got a few very good examples over the last days here with different companies doing different things in optics. I think there are a lot of applications, and if you think about the CHIPS Act and how low amount of money is going to optics, it's basically a very poor thing. So I think we have to promote this more. We have to show examples of what optics can do, and we have to be connected, let's say, with the different governments, and that's what we also try to do.
So just following up on the CHIP Act, I mean, we've seen the CHIP Act in the US and we've also seen it in Europe, but you mentioned in your talk the working with the Canadian government. I mean, how does that work compared to what you've seen in the CHIP Act?
Now, CHIPS Act, it has the complexity not only in Europe but also in the US. That it depends on the state, correct? What you do in the state, and before you have aligned everything and how that's going smooth, it takes a lot of time. What we see in Canada is that you have of course, the province. We have Quebec there, and we have the federal, and there are only two streams of money. And then we have IBM and we have Teledyne working together. So it's far more efficient, and I think the momentum is much faster. It's far more focused. So I'm a bit worried about CHIPS Act, to be honest. And it's, of course, we all know what happened with Intel, which is not a good story. and that's not helping, let's say, to create momentum. I like the Canadian solution a lot more.
Okay, I got one more of a technical question actually. As I was watching your talk, you're doing a lot of sensors, and a couple of questions here. Crystal ball, 5 to 10 years from now. But what I learned was a lot of the work you're doing, you're building up the systems around the sensors. How does that work with your customers? I mean, surely you may be competing with some of your customers if you get systems, or you're building up systems from chips and things.
Yeah, that's a good question. I thought the same thing. I thought the same thing that, we have to be careful. We have to work. By the way, we work very close with our customers. But what I realized is that the customers really like us to do this. We know our sensor best. We know how to get the maximum out of that sensor. They love to us to do that, so that they can concentrate on, let's say, the user interface, the other side, where there's also a lot of software and a lot of hardware involved. So there is a very good synergy. It depends on the customer, of course, and we always try to work with the customer, and we decide what to do. But I was impressed that how many customers really like us to do more close to the sensor.
So that just gives me another interesting question. Sorry about this, but in the telecom space, as you climb the value chain from components to pluggable transceivers, the profit margin on transceivers, which is basically a module type system, gets less. Do you see the same thing in your business?
No, it's in our case it's mostly a small curve. So it's basically you get more margin. Let's say if I take a scientific camera, we sell scientific sensors with all the nice coatings and all the stuff. If we make a camera and get the maximum signal out, the value goes up, probably with a factor 10. The value goes up because it's extremely difficult to do. Extremely difficult to do. So I always see that small curve. I don't see the opposite. I know exactly what you mean. I don't see the opposite. I see the small curve, so the margin's going up.
Nice business to be in. Let me open this up for any questions.
Hello, I'm Kevin Fahey from Market Operandi.
Okay.
So you have a beautiful story of acquisitions in building this synergistic strategy. So normally with large companies, it's easy to acquire other medium to large companies, P&L acquisition and kind of easy to fit in your business. How are you dealing with the small and medium companies that are technology enablers, that are ones that you want to deal with in the future, but aren't yet at the stage where you can think about dealing with them from an acquisition point of view?
Yeah, that's a good question, and I'm very honest here. We're not very good at that. Okay, we don't. Basically, we partner with let's say smaller companies. We partner a lot with them, but we don't acquire. What the typical company we acquire is a somewhat larger company, let's say mid-sized company, profitable, hopefully not too profitable. We can make it a bit more profitable, but that's. No, I'm trying to be transparent on this. We will not buy a startup. We did it before, and that didn't work for us. By the way, we never sold a single company. Of the 72 companies now we bought, we never sold a single company, and they're all doing great. So, but the reason that they are doing great, we probably pay a bit more, and we also don't take a lot of risk, let's say, with it being a small company. However, we continue to work with small companies. We love small companies, and we partner with small companies. With some of the companies we acquired, we worked for 10 years before we bought them. A good example is ICM in Belgium. We worked for that company for 10 years. Torsten Nachtekeer, who's in the audience here, knows very well. 10 years before we bought them. That's how we work. So we don't take a lot of risk there.
Hello. A question for you here.
Okay.
So fascinating presentation. So many applications, so many customers, so many potential opportunities. So my question to you is, how do you manage that complexity? How do you make these investment decisions? How do you manage a business on a day-to-day basis so you're able to prioritize and make the right investment?
Okay, that's a good question. By the way, all the questions are great. But this is a really good question. So first of all, we have to understand the business. It comes back, we will not buy a company if we don't understand exactly what they're doing. What are we doing? How do we see the synergies? Then the second question, who is going to run it? Where is it located? Who is going to run it? That's the second question we ask ourselves. And if that all has, let's say, a positive answer, we step away from acquisitions. Maybe sometimes we're at the very late stage, we step away. But again, we always try to make sure that it is all very accurate, and then we do it. And then the second part of your question, the synergies. I look at the end markets, and I love that way to look at that, because that's how the customers see us. Yeah, because to be honest, if you look at the reporting segments and you want a medical system, where do you go? Could you do instrumentation or digital? I wouldn't know. Yeah, but the end markets you will know. So the good thing is that if you look at all these technologies, there's so much synergy between these markets and businesses. And probably if you look in Teledyne, and some of the groups are called Teledyne Healthcare, they don't do only healthcare, they do defense as well. There's a lot of synergy. So that's my best answer I can give.